Okay, this is section 7.3, angle relationships in Polygon. Although triangles and quadrilaterals are the most common shapes in construction, you will find many other types of polygons in both natural and manufactured objects. The investigations in this section deal with convex polygons. All the interior angles of these polygons measure less than 180 degrees. A concave polygon can have angles greater than 180 degrees. Okay, so concave polygon, think of the most basic concave polygon. You can think of kind of the Pac-Man symbol. So you have this angle, which is an interior angle, being greater than 180 degrees. Okay, so that's the way maybe you can remember concave, Pac-Man. Convex is the other type, which we're used to seeing, the traditional type, where we have our angles all less than 180 degrees, all the interior angles. Okay, so those are our two definitions. Convex polygon, a polygon with no part of any line segment joining 2 points on the polygon outside of the polygon. And concave, a polygon with parts of some line segments joining 2 points on the polygon outside the polygon. All right, another way to think of it, I think a better definition is all interior angles less than 180 and all can have angles greater than 180. That's a better definition, I think. All right, we're going to skip this and go straight to investigate B. There are patterns in the angles. Are there patterns in the angles of polygon? So we're going to set up a table like the one shown. Enter the results of your previous investigation of angles in polygons. Use the table to record your results during this investigation. So how many sides of a quadrilateral? Yeah, 4. So we should have found this from our last investigation, but we'll just add it in. Pentagon? AJ?
5.
Good. Okay. Number of diagonals from one vertex. So we'll draw a quadrilateral here. Number of diagonals, 1. It's really all we can draw, right? So 1. Sorry? But this is number of diagonals from one vertex. So just 1. Right? Or pentagon, so we have 5 sides. 1, 2, 1, 2, 1, 2. So we have 2. Number of triangles in the polygon. So 1, 2. One, 1, 2, 3. See a pattern happening here. Sum of interior angles, quadrilateral, we know is 360. Thank you. And pentagon, yeah, 540, and we know that because of our little formula, which I think is what we're actually trying to develop right here. Sum of exterior angles, we know this, AJ?
360 for all of them?
Right. Okay, draw a hexagon. Label and measure its interior angles. Find the sum of these angles. So a hexagon has 6 sides. Oh, it's right below it here. So here's our hexagon. 1, 2, 3, 4, 5, 6. Here's our hexagon. Label and measure its interior. Find the sum of these angles. So the sum of a hexagon, if we were to measure all of these angles, we would find out that it would be, what? 7, yeah? 720, good. Okay, so 720 degrees of all the interior angles. Extend one side at each vertex to create an exterior angle. Name and measure these exterior, find the sum of these exterior angles. So sum of all these angles are going to add up to 360. Okay, and you can kind of just visualize that by looking at these angles, seeing how small they are in comparative to, say, a square where you're going to get full 90-degree angles coming off. The more sides, the smaller the exterior angles. Draw a heptagon, label and measure its interior angles. A heptagon has 7 sides. Let's see if we have that drawn. No, I gotta draw it. Let's draw it down here. 1, 2, 3, 4, 5, 6. So a heptagon has 7 sides. It's similar to a stop sign with just the top not having that straight horizontal side. Okay? Extend one of each side. Find the sum of these angles. So the sum of all of these angles now is going to be what? Yeah? 900. Okay, and the exterior angles again. 360. Okay? Any patterns you see for the sum of the exterior angles of polygon? Yes, they're all the same. Heptagon. Any questions here? How we develop this pattern? Is there any reason that we need to kind of actually physically measure them? Are you guys okay with this conceptually? You're understanding this? Yeah.
What's the formula, sir? To find
We're getting there. Yeah, we're getting there. We're almost there. How many diagonals can you draw from a vertex in each polygon? How does the number of diagonals relate to the number of sides? Use a scatter plot or first differences to help identify the relationship. So, diagonals are the lines we can draw from a vertex, so a point where 2 lines intersect, to the opposing sides, or the opposing vertices. So 1, 2, 3, 4. Can't draw this one because it's already a line, right? So 4 diagonals for my heptagon, 4, and for this one, 1, 2, 3. 3 diagonals over here. Okay, and how does it relate to the number of sides? Well, if I have 7 sides, I have 4 diagonals. If I have 6 sides, I have 3. If I have 5 sides, I have 2. So it looks like it's 3 less than the number of sides. How does the number of triangles formed by the diagonals relate to the number of sides? So if this pattern is the same, we would have 3, 4, 5. So number of sides, number of triangles, so it's 2 less. So your number of triangles is 2 less, your number of diagonals is 3 less. Makes sense? Explain the pattern in the sums of the interior angles of polygons. Write an equation for this pattern. Describe how you can use this equation to find the sum of the interior angles of any polygon. Nicholas?
So with the lines would be n minus 3.
The lines or the sides?
The
So-
lines in comparison to the sides. I mean, yeah.
The pattern in the sums of the interior angles. Write an equation for this pattern. Describe. We're looking for that equation now, right? Tyler?
So we've mentioned this equation before. It's n subtract 2 multiplied by, I think, 180. Where n is equal to the number of sides of the ocean.
Yeah, so there's the equation. Okay, Joseph? So the number of sides of your polygon, subtract 2 times 180. So if we try that for our table here, triangle, subtract 2 is 1 times 180, we get 180. Quadrilateral, subtract 2 is 4 minus 2 is 2, times 180 is 360. Pentagon, 5 minus 2 is 3, times 180, 540. Okay, so it works. Any questions? All right. That's Geometry Sketchpad. We may do that exercise again if we do another day with the laptops. Example 1. Calculate the sum of the interior angles of an octagon. Octagon has 8 sides, so we use our nifty formula, which is right here. We sub in 8 for n. So 8 minus 2 is 6 times 180, 1080. Any questions? Very easy. Find the measure of each interior angle of a regular octagon. Regular polygon, a polygon with all sides equal or all interior angles equal. So important definition here. A regular polygon means that all the sides are equal. So a triangle has got a special name, a regular triangle. What would we call it? Henry? Good, an equilateral triangle. A rectangle, regular rectangle. Sebastian's got a special name. What's it called? If you don't go to the party, somebody might say you are being square, yes. All right. Square, all the sides are the same in a rectangle, right? It's a square. Okay, interior angles in a regular octagon. Here we go. It says find each measure of the interior angles in a regular octagon. So a regular octagon, we know there's 8 sides. So we'll do 8 minus 2 times 180. That will give us our 1080. Once we have our 1080, we know that all the sides are the same, but additionally in a regular, if all the sides are the same, just like an equilateral triangle, what does that mean about the angles? Matthew?
They're all the same.
Yeah, they're all the same. The sides are the same, the angles are the same. So we know that there's going to be 8 angles. So we divide 180 by 8. We know that our angles is 135 degrees. Okay? Any questions? We could use supplementary angles. I prefer the formula, but if we wanted to use supplementary angles, we could. Let's see that method. So the sum of the exterior angles is 360. So this is, they're using exterior angles now. For a regular octagon, these 8 angles are equal to each other. So we use exterior angles. So 360 divided by 8 is 45. And then we find the inside angle by subtracting that outside angle. So if we know that this is 45, we know that this whole angle here is 180. So we know that the interior angle is 135. Okay? Any questions there? All right, we're good. Finally, last example. Find the number of sides. How many sides does a polygon have if each of its interior angles measures 140? Okay, so we know the interior angles are all measuring 140. So we know it's a regular polygon. We know that because they're all the same. And it has 140. So an n-sided polygon has n interior angles. If each interior angle measures 140, their sum in degrees is 140n, right? Because we're going to take 140 degrees, multiply it by however many sides there are. The sum of the interior angles in degrees of any polygon is 180 n minus 2. Therefore, we can set 180 n minus 2, which is the sum of all their angles, equals to 140, which is each of them, how much they are, multiplied by how many there are. Anybody confused by this equation? Because this is the hard part. After this, it's all downhill. Anyone confused how we got there? AJ?
Sort of.
Okay, let's talk about it again. So we know that this polygon, we don't know how many sides it has. Okay, we don't know. We just know that each side is 140. Okay? So if each side is 140, we know that the total angles are going to be 140 times however many sides it has, correct? So we know that the total angle is going to be 140 times n. Do you understand how we're getting that, 140 times n?
Yeah.
We also know from our general formula that the total angles in any polygon is equal to the number of sides, n, minus 2 times 180. So do you understand now why and how we can set those two equal to each other?
Yeah, and then you just solve.
Yes. Sal? I just want to make sure you understand this step because that's the important part. This stuff here is just review, right? So now we're going to use distributive property 180 times n, 180n, 180 times 2 is negative 360, sorry, negative 2, Now we're going to gather like terms. So the 140 moves over to the left side, becomes negative. 180 minus 140 is 40. And the 360 moves to the other side, that becomes positive. We solve for n is 9. The polygon that we're referring to then has 9 sides. Any questions? We can do that for any regular polygon. If we know what one of the angles is inside, we can solve for how many sides. Now, just like we've done here. Okay, so if I say I have a polygon with sides of 60 degrees, how many sides are there? We can use that formula and figure it out, right? It's going to be 3, right? It should be 3. Because we know triangles have angles of 60 degrees. Yep.
Is that n beside 140 necessary?
Yes, it is, because you need to combine it with the 180 to make 40 over here. If you just put 140 here, Luca, it's going to combine with the 360. And you're going to get a different answer. Okay? Also, you need it here because this, remember, this formula is equal to the total angles, or the total, all the angles added up. So if we just did 140, that's not equal to all the angles added up. It's only equal to one angle. That's why you got to multiply it by the number of sides. Okay? Remember, the number of sides is always going to be equal to the number of angles inside. Yeah?
So what do you do if you only have the sum of the angles?
Sorry, which sum of what
Okay,
angle?
let's say you have the sum of all the added angles together, all the interior angles. How would you figure out the...
Oh, okay, like this. So 1080, let's say, is the sum of all interior angles. Set that equal to 180 times n minus 2. Okay, we know it should be 8, right? Because we've already done this, but let's do this. Okay, so we divide by 180. So these cross out. What's 1080 divided by 180? Yeah? No, it's not 10.
6.
6 is equal to n minus 2. N is equal to 8. See? Good question, Max. See how it works? Christian?
See if that equation has 180 equals, 1080 equals 180 n minus 2.
Mm-hmm.
Could you multiply use distributive property, multiply 180 n and then 180 by negative 2, and then apply that to the rest of the equation, and we get a different answer.
Yeah, you could. All right, let's do that.
So it would be 180 minus negative times negative 160.
So Christian's just asking, you guys can see this, right? He's asking, can I multiply this out? Sure can. Right? So leave the 180 on its own over here. The 360 is going to come over and be positive. 360 plus 1080 is 1440, I believe.
Yeah.
So 1440 divided by 180, I'm going to guess, is 8. Yes. Okay? Either way works.
Yeah, that's how I thought of doing it.
Yeah, that's fine. Anybody else? Questions? All right, summary. The sum of exterior angles of a convex polygon is 360. Good. For a polygon with n sides, the sum of the interior angles in degrees is 180 times n minus 2. Any other questions?